Let's take a look at lesson 11, talking about finding midpoints on a number line and on a coordinate plane. If you have a number line, like so, horizontal or vertical, in order to find the midpoint, say we're trying to find C, the formula would be C equals A plus B divided by 2. That'd be how you find the midpoint on a number line. So really quick, we'll look at example 1, A. If we're trying to find the midpoint between points A and point B. Point A is 2 and point B is 6. So we would add, so we'll call it M for midpoint equals 2 plus 6 all divided by 2. 2 plus 6 divided by 2. So we would do the top part first in the numerator. 2 plus 6, 8 divided by 2. Your midpoint would be 4. You could count and see that that is correct, but that is just showing you how to do it algebraically. So that's on a number line, pretty simple there. Next one is on a coordinate plane. If we're trying to find the midpoint on a coordinate plane, the formula here I'll show you and then we'll do a practice problem. For midpoint is x of 1 plus x of 2 divided by 2, y of 1 plus y of 2 divided by 2. That is your midpoint. So if we have in example 2b, or 1b, sorry, example 1b, we have coordinate 1, 2, and 5, 6. And we got to find the midpoint. Line slanted, so we can't use the number line system. We got to use what we have here. So what we need to do is identify our x of 1, y of 1, x of 2, y of 2. We're going to call this one our x of 1. If that's our x of 1, that means this has to be our y of 1. Remember, coordinate is always x, y. And then that would make this x of 2, y of 2. Plug those into our formula. X of 1, okay, 1 plus x of 2, 5, divided by 2. This is in parentheses because it's a coordinate. And then y of 1, 2 plus 6, divided by 2. And then you would solve. 1 plus 5 is 6, divided by 2 is 3. 2 plus 6 is 8, divided by 2 is 4. So therefore your coordinate, that is the midpoint, would be 3, 4. And you can see that it looks like it would be the midpoint. And that's all there is to a lesson 11, finding the midpoint on a number line and on a coordinate grid. Now let's look at lesson 12, page 71. This is very similar to investigation 1. There's really no math on this one, but just a couple of definitions to help you understand the concept further. Lesson 12 is proving lines are parallel. We have postulate 12 that says the converse of corresponding angles, that is the corresponding converse of corresponding angles postulate. What we had in the past was we said if we had investigation 1, if we have two parallel lines cut by a transversal, we already know these are parallel, then we know that angle 1 and 2 are corresponding angles and that they would be congruent. But we knew that they were congruent because the lines were parallel. What this is saying, if you remember converse, that word converse from lesson 10, I believe, that now we're just switching from if P then Q to if Q then P. So here we said if two lines are parallel and cut by a transversal, then corresponding angles are congruent. Converse would be if you have two corresponding angles that are congruent, then the lines must be parallel. And that's all that is. You have the same converse for alternate interior. If you have two alternate interior angles that are congruent, and you can see that from their little sign here, then you know that the two lines that are cut by the transversal are parallel. Same thing with converse alternate exterior and converse of same side. Converse of same side a little bit different because converse of same side in interior angles would state that if 1 and 2 add up to be, if angle 1 and 2 add up to be 180 degrees, then the lines would be parallel. So if angle 1 was 70 and angle 2 was 110, those are supplementary. They add up to be 180 degrees. Therefore, the two lines are parallel. And that's just another way to prove that lines would be parallel. And that is all that there is to lesson 12. Very short, brief, easy definition lesson.